Good afternoon to Doctor and members that in front of us. And today we are going to present about the automatic assignment tool where the selection of the parts is differential. My name is Lim Kai Wen and I have another teammate which is Fu Gui Ping. We are from 4 BMMD 1/1. What is about differential? Differential is a combination of gear train where it consists of the bevel gear, axial shaft, ring bevel gear, axle housing, and etc. It is a system that transmits the power from the power engine, from the crankshaft to the gearbox, and differential, and finally is to the left and the right wheels. The differential is placed between the left and the right axle shaft. We can see where the differential is located from the animation on the right hand side from here. Okay, here is the components that I mentioned before. We have a bucket carrier, ring gear, axial shaft, housing, differential side gear, and we have a pinion gear and also pinion shaft. But in this simulation, we are only pick the big ring bevel gear to simulate in between a pinion gear. Okay, so we can know what is the relationship when we trying to apply the force from the gearbox to the differential before we transmit it or separated the power to the left and the right wheels. So why differential is designed and used in the automobile or automotive application and fields? The main function of differential gear is allowing the outer drive wheel to rotate faster than the inner one when a steering is take a turn, or we trying to turn the steering from one angle to another angle. So from the animation from here, you can see the arc length for the left and the right one is different, which means that the distance they taken is also different, where the inner one is shorter than the outer one. So means that the outer one need to turn faster or run faster than the inner one, so that we could balance the distance travel when they are trying to take a steering turn. The total speed transmitted from the gearbox is distributed to the left and the right, controlled by the carrier. So the main function of the carrier is to control the speed of the left and the right when we trying to turn. When we turn on the left, maybe this one will turn more to the left side, and the bevel gear and the pinion gear over here also will be contact more area. Okay, here is the simple concept. So in this assignment, we are going to use the differential to simulate and apply different materials to see what is the tensile strength, what is displacement, and also etc. For the differential assembly, we had drawn 5 parts. Okay, we selected the parts from the original design, so we drawn it in the Solidworks. So separated to the axial shaft, bevel ring gear, bevel gear, and also axle housing. So this one is a CAD drawing for those parts that have been hand drawn, and overall we have 5 parts. Okay.
Greetings everyone, I am Fu Gui Ping. I will start my presentation with the selection of material for the different parts of differential. There are 5 parts for differential. They are pin, differential cup, bevel ring gear, we also call it crown gear, driving pinion, and we also call it spiral bevel, and right axle shaft. The material for pin, differential cup, and right axle shaft is aluminum alloy. The reason that I choose aluminum alloy is because it has certain strength, light in weight, and doesn't apply on the core motion energy transmitting part. For bevel ring gear and driving pinion, I will choose AISI 4340 steel anneal material because it is high in strength and suitable for high torque and high RPM application. which are the characteristics of a gear needed. The process selection of pin and right axle shaft are same, which is hot extrusion, forming and lab. Differential cut will use casting and molding, while bearing gear and driving pinion are using die casting, sand casting and molding.
In this differential design, we are going to choose two parts as our simulation parts. First is the ring bevel gears, second is the pinion gear. So these gears we are going to use the same material, and also they are produced by using the same ways. There are three manufacturing process. First one is a die casting, second one is a sand casting, and third one is the milling casting. Die casting and sand casting will be going through the final process. We are also using milling machines to conduct the finishing process.
The first method, die casting, start with the procedure of mold preparation, injection preparation, and then molten injection. Let's start with mold preparation. Two mold upper part and the lower part with the cavity shape of bearing gear is prepared. Then it can go to injection preparation process. The desired material for bearing gear is heated in the furnace until the material becomes molten state, and then spray the lubricant on the cavity surface to prevent the die casting stick in the mold after solidification. After that, two molds will assemble compactly and ready for mold injection. The molten injection is the process that the ram or plugger is used to inject the molten state material into the mold cavity. After the solidification is done, the mold are opened and then the die casting is taken out. A very little finishing is needed if necessary. Next. This is the simple overall die casting process. The mold is ready, the molten is ready, and then the mold is sprayed and closed. Then the project pushes the molten into the cavity. So after solidification, casting taken out and ready for next casting by spraying the lubricant in onto the mold again. Next. The sand casting procedure are the same as YouTube tutorial that sent by Doctor. So I think everybody is familiar with this. So I will only go with the summary of this manufacturing method. The sand casting is start with prototype preparation, then sand mixing, then first flush preparation with prototype and lime powder on the prototype and cover with compact sand. Next. Then the second flush preparation with the presence of spool, then separate the flush to build gate, take out the prototype and then ready for casting. Then the method is melting down to molten state and pour it into the sand mold. Finally, the finished casting product is done and ready for finishing.
To manufacture a big ring bevel gear with the milling process, we could combine the process with the milling and the lathe machines, where it comes down to a mine and lathe machine with the 5 axis also, and maybe more than that. The process is started with the design, and the design is completed after we coding out. We using the CAD/CAM software, and the coding is transferred to the machine, and the process is started and your tools is changed. So the machining process for here is a general process that we know. The mold piece will be cut, slowly cut by the 0.5 mm depth. In the milling of the gear, in the bevel gear, they actually cut the workpiece. At the first, they cut slowly for getting a shape. Then after that, they cut through 1 mm and 1 mm going through. When the process is done, it is using the mechanical meter gauge to measure the accuracy of the milling process, of the machining process, to find out which teeth have the bad quality or bad dimensions and will be rejected by QA. Same goes to the sand casting and the die casting. When they are done their process, then this product will be sent to the machining process, which are milling process. So the parts is arranged in the line production, and all the process will be done by using automatic robotic arm, and the process is completed automatic or automations, including the milling machine, which means that from starting the product is placed on the track or on the conveyor, and the parts will be transferred to the milling machines one by one, and finally to the human inspection, which is the mechanical tutorial meter gauge inspections.
This topic is the simulation of the gear in differential. Both gears are actually using the same material and doing the same type of work, which is using the tin of the gear to transmit motion energy. So, as the slide shown, the simulation will be simplified by using only the bevel gear and apply the force of torque to 3 faces of the tin. Only 3 faces are selected because the pinion and bevel gear only have maximum 3 tins interact in the same time. Next, the material that we use in this simulation is AISI 4340 steel, alloy steel, and 2014-76 aluminum alloy. The setting used is 100 Newton torque on 3 faces of the gear, which simulate the faces that contact with the pinion gear. And then, middle circle is fixed. The mesh that used in this simulation is the finest mesh. Let's see the simulation result of the bevel ring gear. Next. Okay. The simulation result of these 3 materials are very similar, but only different in the parameter of the current represent. So I only put 3 pictures on this slide, and let's go to the table of result and evaluate. The result of these 3 materials is interesting. The aluminum alloy has the lowest mass and lowest maximum stress. The alloy steel has the highest maximum stress and lowest maximum displacement and lowest maximum strain. These data show that the alloy steel had faced the highest stress, but it still can retain its shape. However, aluminum alloy has had lowest stress, but its shape is changes in highest level when comparing these 3 materials. For the last material, AISI 4340 steel, it is fall within alloy steel and aluminum alloy. As conclusion of this presentation too, we had explored and understand the basic components that are available in automobile. The process of overall gear manufacturing method are quite similar and depend on the application. The die casting and molding are providing a high accuracy in dimension and require less finishing process and time to produce, while sand casting can produce a large quantity with low accuracy and require more finishing process. Lastly, the alloy steel is good to produce high torque and high RPM application, while the aluminum is good in lightweighting the car. Next. That's all for our presentation. Thank you.